Okay, number 7. A ladder 10 feet long is leaning against a building. All right, so let's draw the building. And let's say that's the ladder right here. And the ladder's 10 feet long. Here we have a right angle. The bottom of the ladder is being pulled away from the building at the rate of 3 feet per second. Okay, so let's say if we call this X and this Y, if the bottom of the ladder is being pulled in this direction away from the building, then X is increasing at the rate of 3 feet per second. All right, so that means dx dt is 3. How fast is the distance from the top of the ladder to the ground? Okay, that's y, this distance, changing when the base of the ladder is 6 feet away from the building. All right, so we're asking what is dy dt? So we're asking what is dy dt when the base of the ladder is 6 feet away from the building, that is when x is equal to 6. Alright, so we're going to have an equation that relates x and y, and that's the Pythagorean theorem, x squared plus y squared is equal to 10 squared. Alright, so let's write that down. So 10 squared, or 100. And now we want an equation that relates dx dt and dy dt, so we'll differentiate our equation with respect to t. Okay, so here we have 2x dx dt plus 2y dy dt is equal to 0. Now here I did not bother eliminating one variable before differentiating because the two variables are in separate terms. We don't have to use a product rule here. It's not difficult to differentiate this with respect to t. Okay, so we're told that dx dt is always 3. Okay, so this quantity here we can replace this with 3. This is equal to 3. Alright, so we have and now what we want to find dy dt when x is equal to 6. Alright, so we're going to solve for dy dt. We're going to substitute x equals 6. But what do we substitute for y? Well, we have to figure out what y is when x equals 6. So now we want to figure out what y is. So when x equals 6, the question is, what is y? We're going to go back to our Pythagorean theorem to figure that out. Okay. So we have x squared plus y squared is equal to 100. So 6 squared alright, so we have continuing over here, we have 36 plus y squared is equal to 100, and then just subtract 36 from both sides. We have y squared is equal to 64. So when x equals 6, y is equal to 8. So now we're substituting x equals 6 and y equal to 8. into the differentiated equation. So let's do that. Remember, dx dt is always 3. So now we have 2x, that's 2 times 6. Dx dt, that's always 3, plus 2y, that's 2 times 8, dy dt is equal to 0. So now we have everything in place for solving for dy dt. Alright, so we have 16 dy dt is equal to, I'll subtract this term off. Here I have 2 times 6, that's 12, times 3 is 36, is equal to minus 36. And now we just divide, and dy dt is equal to minus 36 over 16. Okay, divide top and bottom by 4, and we have minus 9 over 4. Alright, and that would be feet per second. Okay. Notice that y is negative, and this makes sense because if the ladder is being pulled away this way, then the top of the ladder is coming down and y is decreasing. Okay, so that makes sense. Okay, let's continue with number 8. We want to find the absolute max and the absolute min of f of x equal x minus 2 squared on the interval 1, 5. Alright, now absolute max and absolute min we usually find on closed intervals, and the way we do that is we check, we evaluate f of x at the endpoints at 1 and 5 and at any critical values that fall in this interval. So let's first find some critical values. See if we have any critical values in the interval. Okay. So we're looking for critical values. And those occur where f prime equals 0 or does not exist. But f does exist. Alright, so that's where we get critical values. In this case, f is a polynomial, so we're only going to find, and f prime is going to be also polynomial, a simple expression. So we're only going to find critical values where f prime is equal to 0. So let's calculate f prime. F prime of x is 2, x minus 2. Alright, and when is that equal to 0? Well, that's equal to 0 at x equal 2. X equal 2 is in our interval between 1 and 5. Alright, so that x of 2, that is in our interval. So now we're going to check the values, or evaluate f. We're going to evaluate f when f is 1, 5, and 2, and just see which is the max and which is the min. Okay, so f of 1, that's 1 minus 2 squared, that's 1. F of 5, 5 minus 2 squared, that's 9. And f of 2 is 0. So we have a maximum here, and we have a minimum here. So that's the absolute max, and that's the absolute min.